All right, so everybody, first I want to mention an opportunity for each of you to earn up to $100. If you go to our textbook, you will now see a new link. Come on, where's the textbook? You will now see a new link right here, right underneath the center that says volunteer for interviews, and you can read that. We're interviewing people on how they're understanding the ideas of calculus and how they're using the book in order to help them, both of those questions. You are not paid on whether you get right or wrong answers. You are literally paid for your time, okay? It's really not very, like some people are like, oh, I don't want to do this, but please volunteer. It's a great opportunity to earn $100. We need it to help you continue improving the class. I will not be interviewing you because it has nothing whatsoever to do with your grade, okay? So the other people interviewing you, so there's like this clear separation between grade and that. And you literally get paid by sitting there, drawing on an iPad and talking about how you're thinking about things. Alex?
Is it one thing of $100 that's given to
It's
one?
It's 4. So for each interview you get $25, and we will ask you to get interviewed up to 4 times.
But it doesn't matter. Like it's not like they don't choose one person to get this.
Oh no, we need like 35 people. So yeah, everyone. So if you go to the textbook, it's right here. Okay? Volunteer for interviews. There's an email. Send an email saying I'm interested, and say whose class you're in, because we're interviewing both the people using this curriculum and the people using the more traditional textbook. So please do take advantage of that. A second what? No, that is the wrong PowerPoint. Here we go. A second announcement I want to make is people have been saying in office hours that even if the homework assignment asks you to use GC, a lot of people are coming in and not wanting to use GC. You really need to use it because tomorrow, this time tomorrow is accurate. It is tomorrow. Tomorrow we're going to start talking about function notation, and GC can use function notation in a way that handheld computers and Wolfram Alpha and the other kinds can't. So please make sure that you're practicing GC and using that cheat sheet. All right? And let's go ahead and begin. So today, first I want you guys to discuss in your groups. I should hear you talking as I walk around. Both is it a function and you need a reason. Go. Take this. But think about where the vertical line test comes from and do that.
But have more than one entry for it is a function. Sometimes in the vertical line test, there's i.e. for every x there is a y. So for
Okay, is the function, everyone, poor man's clicker, just yell an answer, 1, 2, 3.
Yes.
Wonderful. Who can tell me, I noticed some people already being like, no, you can't just say vertical line test. You're starting to read my mind. Because I heard a lot of people saying that and a lot of people saying no. So who can give us an explanation? And you know what, it's very related to the vertical line test. It's just that the vertical line test has to have meaning for you instead of my teacher taught me to draw a straight line, so I did. So who can tell? Me.
Yes. Every x has one y value.
Wonderful. For every x value, there's only exactly one y value. So let's talk about it. So we have the idea of independent and dependent values. What makes them a function? And so I'm going to give you guys a couple of analogies, or actually just this one analogy. All right, consider making a call with your phone. What's going to be the independent variable and what's going to be the dependent variable? Anybody? There's an independent variable, right? And then there's a dependent variable in this situation. Wonderful. The phone number is the independent variable. All right, and then what would be the dependent? Let's see. Come on, I want to try. Please don't stop raising your hands. If you're the people that raise your hand a lot, I just want to want to get a bunch of different people. Maverick, go ahead.
The person who answers.
Perfect. That's the independent variable is the phone number. The dependent variable is the person or the place that you're getting to, right? And so the whole point is that if it functions properly, then if you dial this number, you get this recipient. If you dial this number, you get this recipient, and so on and so forth. All right. I borrowed this one side from someone, so I don't know where it ends. There we go. And I heard some people using this language. For each value of the independent variable, or in that graph we were talking about x, uniquely determined, right? There's only one output. Now, what about a situation where you... Oh, he really goes a lot with animations. What about I dial this number, and sometimes it gets to my mom, and sometimes it gets to pizza delivery. Is my phone functioning?
No.
No, your phone is not functioning. You need to get a new phone, or need to get a new wireless service provider. It is not performing a valid function. Is there another situation besides just one-to-one that could be a function? Wrestling?
Where your mom has both a work phone number and a home phone number.
Perfect. What if we have two different numbers, but they both go to my friend because he has a home and a cell, or a work and a cell? Is this a valid function? Is my phone functioning the way it should? Yeah. Right? So, and likewise for the credit card company. So a lot of times people start to think a function as one-to-one, but you need to be very careful that it is not. Each independent value has only one dependent value, and that's what makes it a function. All right, so now let's do a couple of examples. Come on. There we go. All right, I visit a lake with my friend, or you do, and you take a bunch of data on temperature, on the frog croakings that you hear, and on the cricket chirpings that you hear. And you get these two graphs. All right, so what is the independent and dependent value for each of these graphs? And are they functions? Go. For this one, unless I say otherwise, because of course it's not universally true, but what's like the default assumption on a graph? The horizontal axis is the independent variable, right? However, I can give you a graph and stay in words and type at the top to think about it the other way. But if someone doesn't say it, you assume. All right, so the independent is the number of ribbits in 1 minute or the number of chirps in 1 minute, and the dependent is the temperature. For this first one, come on, is it a function? It is not. In other words, I give you the number of ribbits I heard. Are you immediately able to uniquely predict what the temperature is? No. What about the chirps? So here I gave you a couple of numbers. This time is the function. I'm hearing a mix. I'm hearing mostly yeses, but some no's. Okay?
Yes, because each number of terms has its own temperature.
Wonderful. All right. And so it is a function. The fact that there's two 70s there doesn't matter. Turns out that if you hear both 94 or 97 chirps per minute, both of those represent the fact that it is 70 degrees, and that's okay. Okay, so now my question is, I want you guys to again look at, come on. Okay. Another important point is, that we'll talk about later, do you see how all of these mean that I can give you the answer? To be a function, it doesn't mean I can give you the answer. For example, let's say that I know now that this is a function. If I ask about 90 chirps per minute, does that all of a sudden mean I'm not talking about a function anymore? because we've decided, and actually it turns out to be really reliable, that you can count cricket chirps and predict the temperature around you. It turns out to be a very reliable function. Just because I don't know the number doesn't mean it's not a function. It's that I know there'll only be one number. Do you see the difference? So lots of times people get mixed up with functions because they say, well, I don't know how to find the answer. It's not whether you know how to find the answer. It's whether, who can answer that? Who can kind of fill in that blank? Take a minute. It's not whether you know what the output's going to be. It's whether you know ahead of time, you're really certain there's only going to be one output. Okay? Wonderful. So now let's look at this. You guys said that this is a function, right? And now let me ask you this. Is it still a function?
No.
All right? But if you notice, isn't it all the same x and y values? Like the x and y, I put it on this graph so that it rotates.
Oh.
Right? So this time I'm being very serious. I want x to be, like, don't assume that this is x now. That's still y as it rotates. All right? So take a second and discuss in your groups, do you think this is a function or not? I located the label along us. So what was the y function? Y axis before it's still the y axis. What was the x? All right. I just want the answer to this rotated one. Yes or no? Everybody yell at answer. 1, 2, 3.
Yes.
All right. Have all yeses. How can you reconcile that with the fact that it doesn't pass the vertical line test? Vertical line test doesn't matter. Christian, what do you say?
Vertical line test changed to a horizontal line.
Okay. What about over here? So what I want to do is, and all of you guys are absolutely right, but here's the thing. We're still talking about it, right? As if this is one thing. And instead what I want us to do is, we're no longer going to ask the question, is it a function? Instead, I want you guys, let me go ahead and rotate it back to the, you guys know what it looks like. I want you guys to write down 2 sentences about this graph. And one of those sentences should have the phrase is a function in it, and one of those phrases should have is not a function in it, and they should both be true about this graph. Go. In your groups. How can you write 2 sentences, both equally true and valid at the same moment about this graph?
It's not a function. We say it's not a function.
No, it's not.
Negative.
Oh, yeah, you can use other words. So yep, on this graph. You should be able to write a sentence accurately about the situation of this graph that has the word is a function. So one, you should be able to say, oh, it is a function, and then you should also be able to say it's not a function. And how about the same graph? About the same graph.
This graph is a function.
Oh, and that's a great hint. Don't use the word it, right? Because what's it? Be more specific. This graph is showing me a function. I'm seeing a function, and I'm seeing a not function right now. Yeah. Well, right now, I can look at this graph and I can say, I see a function there. And I can also look at this graph and I can say, I can see a non-function. And so how do you do it? I'm literally making nothing. I'll tell you the answer.
It doesn't seem right. It's not natural.
So can you go ahead now and pretty much there. Can you now? I mean, let me make it a little bit easier. All right, here's an additional part. Fill in these sentences. It's the same thing as you did before, I'm just giving you a little more. Keep discussing for another minute or so. Right now, what you guys are doing is you're showing me that the forefront of your mind right now.
So I think we have to relate the action.
Remember how we talked about that?
So it's like saying, let's
You
know
graph
X
that.
is
Can you give that a question?
I'm like having it all backwards, exactly.
As you're writing, please share with the people around you so that you can see what each other is writing.
Yeah, exactly. So I think I might, I mean, I may have like the order wrong. One is like the graph, and it's because yeah, and I'm not.
Yeah.
Oh my god.
That's what I'm thinking about, yeah.
They don't know that on paper.
Still.
I remember reading that thing where you just like saw those yeah.
What about right after class tomorrow? And then
That's why I was late.
So are we adding something?
I don't think it's working.
I'm actually on time for once. Wonderful. All right, volunteers. Who thinks they can plug them in? Sophia, what do you think for a function?
X is a function of y, but y is not a function of x.
X is a function of y. Y is not a function of y. Y is not a function of. Anyone have anything different? You're on the right track. You were saying, we actually need to switch them, but that's all right. I'm going to explain in a second. You're starting to think about it not as a thing, as a piece of wire, but as a representation of x and y, each representing the values of two different quantities, right? Wonderful. The only thing that we need to add is a function. So this is actually something that's useful. If you write is a function, the way we interpret it is which way is which. It's always that the dependent value is a function of the independent value, right? Because it's this is determined by this, okay? So it's is a function is uniquely determined by, is dependent on, and I'm blanking out on the fourth phrase, so I will put it in my PowerPoint for tomorrow. There's one more phrase that we kind of commonly use, and so we just need to fix them because y is a function of x. Because for every x value, you only have one y value. Okay? X is not a function of y because for every y value, you don't have only one x value. The last thing I want to add, in the same way that we do not think about a function as you have to be able to predict it, it's not a formula, and we're going to talk about them more tomorrow. Just because you don't have a formula for something does not mean that there's not a function for it. So there's going to be reading for tomorrow, but not homework. But start your homework, and don't wait until after Tuesday because there will be homework due Wednesday. Okay? Please make sure that you're taking advantage of office hours, and if you can't get to my office hours, everyone on that list knows everything that we're talking about, and you can also email me for appointments.
Are you gonna
Yeah, I'll post it within like the next 15 minutes. All right, have a good day, everybody.